items. And actually, if I didn't get a chance to meet all of you, my name's Liz Velarde, and I'm the recruiting associate here at the foundation. We also have two other members of our recruiting team here. We have Sarah Roth, who's our senior technical recruiter, and we also have Amy Elder, who's our director of recruiting. And I think she's still checking a few people in downstairs, so she'll be up in just a minute. But if any of you are interested in talking to our recruiting team after the talks, feel free to come up to myself or Sarah or Amy, and we're more than happy to talk to you about maybe career opportunities here at the foundation, or your resume, career search, or if you just want to say hi. So I'll go ahead and jump into the housekeeping items. Hopefully everyone had a chance to grab some pizza and some drinks. The restrooms are towards the back. So the back of the room, down the hall, and to the right. We have signage everywhere, so you should be able to find them. And then we also have our Wi-Fi password if you need it. It's 1, like the number 1. Edit can make a difference. And we have it written there as well as on some yellow signs. So if you have any questions, just feel free to ask me. And as far as, I also have to mention the emergency exit, just in case. It's just right behind you. And moving on to the agenda, our first speaker is Grace Nolan. She's from outside of the foundation, and she's actually in New Zealand. So she's going to be joining us via Google Hangout. And her talk is going to be on my journey into women in tech and open source research. She is currently a systems developer. So there's Grace. She'll start in a second. And immediately afterwards, we're going to have Chelsea Xie. She's one of our data analysts here at Wikimedia Foundation on the discovery team. And her talk is going to be on data analysis in discovery. So at the end of both talks, like I said, we're going to leave some time left over for networking. Feel free to grab more food and talk to some of our recruiting team if you're interested. And I will go ahead and pass it on to Grace.
Okay. Oh, it's me. All right. So let me just share my screen. All right. Can everyone hear me? Is it good? I'll take that as a yes. All right. So hello. I'm from New Zealand, and this is a talk about a research project that I did. So just to introduce myself, I work for a fiber company in New Zealand. So that's like wholesale fiber optics for networking. And I work mostly in Django and Python with a little bit of Bash on the side. And I'm also really into singing. That's a picture of me in the choir. And I also like doing painting and Photoshop. So I've done quite a lot of research in, oh, sorry, I've just really got distracted by a thing that just happened. All right, so I've read a bunch of research. There's quite a lot here. But before we get stuck into that, just want to talk about how I got into computer science, so you have a bit of context for where I'm coming from. So I was, I guess, pretty interested in computers when I was young. Like I was more the technical one in my family. I had an older brother, but he was like a farmer, so not really into technology quite in the same way that I was. And but I wasn't quite sure what I wanted to do at school. My best subject was biology, but I didn't really want to sit in a lab. And I heard that, you know, it's like lots of statistics, and that kind of scared me a little. So I started out doing design, actually. Like I really enjoyed like computer games and innovation and interactive art. And so that's where I thought maybe I might go wild and do something completely different and do design. But when I was there, it was good, but I didn't quite feel I don't know, quite so comfortable. And then I did this programming paper, which I found really challenging and really interesting. It was like an introduction to like Java programming. And I really liked how it kind of made me feel like it's like, oh, it's interactive algebra. And it's the kind of algebra that I really like, which is great. So I thought, maybe I might want to change and do computer science full time. And that way I can do what's challenging, which is like, the programming and hardware side of things. And then that should kind of clear my way for doing interactive art, which is kind of what I thought I'd want to go into. But then when I started doing computer science, I kind of enjoyed I guess doing the more kind of back-end and logic type side of things rather than doing UI or graphics, which I found really, really hard and very frustrating. But when I went into computer science, I felt pretty confident with computers. And coming from like my background and I guess just feeling really confident. So that was really nice. But then when I started, at about nearing the end of first year, I did not feel confident at all. And I was quite put off. Like I kind of felt like, oh no, I don't know anything about computers and everyone here knows so much and they've been doing it for their whole life, and got really kind of stressed. But I kind of wanted to understand this more because it didn't seem to really make sense to me that I would enjoy computers so much and then suddenly not want to do it anymore. So I came across this book, Unlocking the Clubhouse, Women in Computing. I'm pretty sure most of you would have heard of that. And it was really enlightening. Like I read a lot of stuff in there that made sense and was pretty accurate to what my feelings were about how things had gone. And I learned some really good stuff, like, for example, students feel isolated as a result of their class environment. So in class, you had the loud minorities, the students that would pipe up in tutorials and they would challenge the tutor and they would bring up kind of irrelevant details that really didn't help with the lesson. And it was kind of uncomfortable. Like it really just made me not want to say anything ever in class. And I remember having this conversation after one test where everyone was kind of debriefing about it. And somehow we got into the conversation of how we were feeling in classes and feeling kind of isolated and quite nervous. And it turns out a lot of them had been feeling the same way as me, which really surprised me, like particularly people who I thought were like really good, but they were all feeling quite isolated due to that class environment. And the other thing that I learned, which was quite interesting, which is gender bias indoctrination happens as soon as gender is assigned at birth. So in Spertus, the paper there, it's really, really good. Even though it's old, it's very thorough and goes through, right from the start, which is when infants are assigned a gender, the way that people describe them is different. So for example, girls are described as soft and distant and, kind of like a little bit dazed, whereas boys are described as active and, will play up and things like that, which doesn't really make sense because at infants, like really, most babies are the same. They just kind of want to eat and poop and, I don't know, like just cry a lot. So it doesn't really make sense, to be ascribing those attributes at that time, but people do. The next thing is that things that suck for everything suck more for marginalized groups. So talking with the students who felt isolated after that test, most of them were like white males who came from fairly like affluent backgrounds. And sure, it still sucked for them, but it doesn't reinforce the stereotype. Whereas for women or people of color, already there's this belief that they're not quite as good at technology. So it just kind of like reinforces this idea that they don't belong, which is why it's when I did this started finding out more, and when I talk about this report a little bit more in detail, the kinds of recommendations that I make are tend to apply to everyone, but kind of lift up people from marginalized groups even more. So the next one was sharing struggles with people in a similar situation is very good. Like talking to those students after that test was great, and then continuing to talk and share, because it turns out lots of people were feeling really depressed and unhappy about what was going on. And doing that, really, like having these honest conversations, made me feel more connected, and it strengthened my belonging. But I still noticed that there was, this problem, and just because now I felt a little bit more like I belong doesn't solve this problem. So I created a group called Computer Science Student Society, and we organized events like rock climbing and pub crawl and barbecues and stuff like that. And the first event that we did was a barbecue, just to see if anyone would turn up. And we had around 70 people turn up, and that's the picture in the middle that you can see, which is a really good outcome, like way better than expected. So that inspired us to keep organizing more events. And now it's been about 5 years later, they've got their new logo, and it's still going really strong, which is really great, because when I started this, a lot of people said, it's going to just fall apart as soon as you leave, because that's what happens. We've seen it a million times before. There'll always be somebody come along and do these events, and it's great. And then as soon as they graduate, it's all over. But it's really cool to see that it's still going. And there's also another group associated with it, which is right next to them, which is Ladies Inc. And a student that I was mentoring had been working on that. So Ladies Inc. is Ladies in Computing. And that's another group that's also doing really well, even after the founder has left. So that's really like positive to show. I also started doing outreach, so talking to students about computer science, and that was really interesting, because I started learning like a whole lot more about some of the problem areas in outreach, like perceptions and teacher professional development and training and funding is really difficult. Teachers don't get very much time off to do professional development, and there's very little funding. Which has meant that organizations like Google are organizing events like CS4HS, which is computer science for high schools, and that's for teaching teachers how to teach computer science and stuff like that. And also ongoing collaboration and cohesion between teachers is pretty challenging as well. There's so many resources out there now to try and help teach computer science that it can be really overwhelming, and it's hard to sift through which ones are really good and going to work for their students. So these are some of the challenges. So let's go into those in a little bit more depth. Stereotypes are a thing. So this is something that appeared a lot in the research that I did. So there's one study in particular that I'll talk about, which is that they did this experiment, which was set at a university, where they paired up students, where one of them was an actor and one of them was a participant. And these were just really short discussions about what each of these students did. So the actor did computer science, and the actor was either would fit the stereotype or would not fit the stereotype. And right after this meeting, the participant was surveyed, asking if they would consider a career in computer science. And what they found is that if a student fits the stereotype, regardless of if they're male or female, if they are kind of exhibiting those stereotypes, then students are not really interested. They're less interested in going into computer science. And then when they found if a student was breaking the stereotype, then they were more likely to consider it. So just to define what stereotype looked like in this case, stereotypes included people who wore cargo shorts, socks, sandals, and who were interested in computer games. And people who broke stereotypes were dressed differently, maybe just in like a t-shirt and jeans with like some canvas shoes or something, and held other interests such as music or sports. So they also did another survey 2 weeks later to ask if they felt the same or if their feelings had changed about computer science, and their feelings were unchanged, which means that after those 2-minute short meetings, their perceptions would last for at least 2 weeks after forming those perceptions. So another one that I want to talk about is stereotype threat. So stereotype threat is, say you're in an environment where there's a negative perception of you. So for example, women aren't perceived to be quite as competent at computers as white men tend to be. So in that environment, women feel like they might have to justify themselves more, or they're not going to be taken seriously, or they're going to be like spoken over. And there's that kind of negative connotation. There's a lot more work to do. So women might just remove themselves out from the situation, which makes sense. It's not really pleasant to be in an environment where you're not seen as credible or valued typically. So this, though, suggests that reasons for not going into STEM extend further than simply not being interested, which seems to be a common thing. There seems to be the first step that, if you ask a professor who doesn't really know much about these, they'll just say, women just aren't interested in going into computer science. So that kind of really debunks that. The next thing is pink washing. So it's really tempting when people are doing outreach to create groups that are for girls, and they'll choose themes that girls might be interested in, like cooking or sewing or these kind of themes. But what this can do is this can actually perpetuate stereotypes, and it can increase isolation and distance between reality. So it's not like a real view of what computing can be like, or a true slice of the different kind of areas that you can go into. So the next thing I'm going to talk about is what's happening in schools in New Zealand. So this is a list of topics being taught in some high schools in New Zealand. It's not in all of them yet, and it's not compulsory. So my high school, for example, did not teach digital technologies or programming or anything like that. But here it's a really good overview of the different subjects. So the number, the DT number, that's you have like level 1 and level 2 and level 3 for the end of high school. And students who are coming through this are really changing the shape of what's happening at universities. So the structure of courses at universities is slowly changing. For example, currently, if you have not done physics in high school, but you want to do engineering, then there's a bridging physics course that you can do. Whereas at the moment, it's just your base computer science degree. So you don't have a bridging course, but they will start introducing bridging courses, and then they'll extend from that. So that way it's kind of skipping some of the basics, but that should change the environment quite a lot. The next thing is that computer science is coming into primary schools. I actually live with somebody, so I live in a share house, and her name's Caitlin Duncan, and she's doing her PhD in this at the moment. And it's showing some really positive results, which is awesome. So this looks like it will be something that will happen. I mean, even in the UK, right, they're doing this already. So hopefully they can get in before those stereotypes are formed, which seem to happen at about 6 years old, some of the studies have been suggesting. CS Unplugged gets a special slide all on its own. I'm not sure if you've heard of this, but it's a curriculum developed by Tim Bell, which is a series of activities to learn things like computational theory and algorithms away from the computer. For example, I did one activity where we broke off into groups and we were each given a number and each group did a different sorting algorithm, and we had to kind of act out what that sorting algorithm was doing, which is a really good way to just kind of understand what's happening. And there's heaps of activities like this, and they're targeted at students in the primary school level, but they're good for everyone, like right up into adults. So this is like a really good way of kind of separating out what computer science is as opposed to just programming as well, which is quite good. So now I'm kind of getting to the end of my degree, and I have learned a bunch of the stuff about what the problems with the environment and difficulties with outreach, and I really wanted to give back. So this is a research project that I did, and that's what this talk is based on. And this was like a summer research project that was pretty much self-directed. I just kind of told the university that I wanted to do this, and the faculty registrar actually worked out a way for me to get funding. But because it was self-directed, I didn't really have a deadline, so it took me months longer than what was expected, but it turned out really well in the end, and lots of people have read it and really appreciated it. So by the end of the project, I had a list of like 20 plus people who actually wanted to be updated on what I was saying, which was really, really awesome. So yeah, it was a pretty good experience, but I mean, my university still was kind of like not really sure. And, there were some people who didn't really want me to do this research. So there was like a little bit of contention there as well. So these are some graphs from my university. On the blue and red one here on the side, these are the number of graduates. So blue is for male, red is for females. And as you can see, there are not very many women who are graduating, but that's slowly increasing a tiny amount each year. And then on the side, the top red and green graph, that's the whole university of number of women and men who are enrolled. So as you can see, there's like a large chunk more females than males, yet in computer science, which is the one down the bottom, you can see that in the same period, it's kind of like it only represents about 20% of female students who are enrolled. Also, to make a note here, these numbers are grabbed from the enrollment forms, and students only have the option of choosing male and female to describe their gender. But there is a push to change that to let people select their preferred gender on there or how they identify. So in summary, these were the main themes that came out of my research. So having no prerequisites is really good. That was something that convinced me to go and change into computer science. Like I remember asking the course advisor there, just really pushing, like, are you sure no prior knowledge is needed? Like, I really don't want to go in there when there's going to be all these people who know everything, which turns out it was kind of a bit like that. Like I kind of, in the end, felt like prerequisites should have been required, but it was good. They did it start from ground zero, which was helpful. It was just the other students who were a bit more off-putting. Allowing students to choose subjects is really good. This gives students like a sense of agency. Working together in the first year, which I will describe a little bit more about that in a moment. Doing summer research projects and letting students kind of select something that they're interested in, and getting mentorship from people within the faculty is really good. Students marking other students' work. So the way that it was done at my university, because it was quite small, they had students physically mark off other students' work. So when we finished an assignment, particularly in first and second year, this is how it works, they would come around and then they would ask you to make a change to your assignment, and that would be part of like the marking schedule, just to show that you'd learned. But also it gave an opportunity for the tutors to notice if a student was struggling. So for example, like I really hated getting help. I'd always be like, nope, I'm fine, like keep moving on. But with this, help was kind of forced upon me in a way, which was really good. Like I really needed that, but it was just kind of too hard otherwise. And paying attention to student environment is really important, like noticing that students feel isolated. Social good and culturally responsive computing. So this is like, what I mean by a possible FOSS opportunity here is working with universities on and FOSS projects could be like a really good way to help enable students to work on something that makes them feel like they're actually, having, well, for starters, they actually have an impact on something else. But that can also be really valuable in terms of like students realizing, their worth and that they can actually give back to the community so soon. Pair programming is also really good, and good course descriptions. So the course descriptions at my university are really vague. Like you don't have any idea of what's going on. When I enrolled for computer science, I just had zero idea of what that even meant, other than, I kind of liked programming. So, I really felt like I was taking quite a leap there. But having good course descriptions can help people understand, especially people who don't know very much about what the subjects are to do for. Another thing was that mentoring is really cool. It's great. It's also very difficult. So I think in tech in particular, it's quite common for people to kind of find somebody that they can ask questions from who kind of act like a casual mentor, mostly because it's really hard to just saying go and Google it doesn't really help in a lot of cases. Like that doesn't help students feel more empowered and stuff like that. But there was this really good study, which I'm going to describe, which is in Germany, they experimented with a mentoring system for girls in STEM subjects. And this was done online. The average age of the female mentees was 13.5 years. And they had a wait list for the mentoring program, which was used as a control group. This program ran for 1 year and returned pretty promising results. So what it showed is that if students have a mentor, then they're more likely to have sustained interest, whereas students without a mentor, their interest drops. So it's not necessarily that it makes students more interested, it's kind of like sustainability of interest in STEM and having that support there when needed. The next one is pair programming in more detail. So these are some of the really key values that that the study found that pair programming helped with. So improved critical reasoning and increased student retention, especially for women. It encourages appreciation of diversity among students and encourages professional and social development. And it improves student confidence in programming, especially amongst women. And it improves the quality of the programs that students write. So particularly early on in the degree, this can make a huge difference, rather than people kind of going away and working on assignments by themselves and struggling and then giving up, which is really what you don't want to happen. So pair programming seems to be really valuable, but yeah, it needs to be actual pair programming as opposed to just divide and conquer. And it works best if students are paired on where they're at a similar level of development. The next one is that conferences are awesome. So this is something that Harvey Mudd encourages in particular. And I think definitely for me, it's really helped. So before I went into computer science, I went to this conference that all my friends were going to, and the tickets were really cheap for students. It was a conference called KiwiCon, which is a hacker conference in New Zealand. And I read the description on the page, and it was really funny. And so I went along having no idea about anything at all. But when I went there, what I found were all these people who were really interested in very technical things, but they were so casual about it, and it was so cool. Like, I just really felt like I'd found kind of my group of people. And I've been going there every year since. And it's almost in the 6th year of going, I actually gave a talk there, which felt really cool. And by that point, they had 2,000 people going there. So it was just a pretty surreal experience. But that just going to those conferences and meeting people really helped make me feel more connected to the wider community, and that there are really cool people out there, and it's not just the students that I was kind of interacting with on a day-to-day basis. One conference in particular, Geelong Linux conference that I went to in 2016. So I met some really cool people there who encouraged me to write this talk, essentially, and to talk about the research that I did. So I was very excited when my talk got accepted. And it started like a little bit of a panic, especially since, you know, my research had been mostly focused on what's happening for students at university and in schools. So I did a survey to see what people thought and if people are contributing to open source or not, and why they don't, and how they got into it if they do. So this is kind of what it looks like. I tried to phrase everything in a way that kind of tried to counter any biases. Like, for example, if somebody is a non-contributor, asking them why they don't contribute can implicitly imply that, you know, they should be contributing and that it's bad that they don't. So I don't actually contribute to open source projects because I don't really have time, and I don't really have I don't really know which projects I want to get started in. And so I just kind of like reminded them in this description. And then at the end, I just asked people to confirm if they were comfortable with me referencing this information. So I have a little disclaimer, which is, you know, I'm not a real statistician, and this is all bad, and it's qualitative study, and I make empathetic decisions, which means the data is going to be a little bit skewed, but, you know, trust me, I've definitely got the gist of this, and it was just for fun and not very good science, but don't at me on Twitter about my bad science, please understand. But also, imposter syndrome manifesto. I kind of realized that you know, what I'm doing in this kind of casual survey is probably more than what, you know, most people might have done. I think that what can happen with some cases like this, or giving talks like this, where people just kind of like don't really connect with the audience that way. So I didn't quite realize it at the time, but, you know, going this extra step was actually really, really good. And I got some interesting results. So this is if you've how many people contribute or not. So you can clearly see that the bias in the audience of people who responded, where lots more people said, yes, they do contribute, than people who don't. So that's quite a good way of kind of like getting an indicator of what we're looking at and the kind of circles that people are from. I shared this with the Sisters mailing list and a few women in tech groups. So there is representation of people from kind of women in tech and other marginalized circles. Otherwise, I just shared it on Twitter and on Facebook and stuff like that. And here were the common barriers to contributing. Oh, also, I don't think I mentioned, but I got like 255 responses, which is way better than expected. Like I thought I was going to get maybe 10 responses or something. So actually heaps of people wanted to share stuff, which was great. Um, so the biggest thing seemed to be a lack of direction / mentor. I thought perhaps maybe it would have been time would be the biggest barrier, but as you can see, that's like the second value there, and that's actually quite a small proportion. Like less than 20% cited that as a reason why they don't contribute. Lots of people felt like they didn't have enough skill, and also the social environment in open source projects and stuff can be really intimidating. Environment setup is too hard, which is definitely one that I relate to a lot. I only have a certain amount of time and patience for like fiddling around with really, millions of packages that you have to install and dependencies and all that kind of stuff. And also, people have other interests in their spare time. And this is how people got into contributing for the people who do contribute. So running into bugs or adding functionality that they need seems to be a really common one. Also, lots of people contributing through their job. So they actually, they get paid to do it, which is great. And also really common to get into it through a friend referring them or a friend showing them. And then there's like university down the bottom, so working on it through university projects. Of those people who say that they do contribute and they talked about some barriers, these are the things that they said were kind of like the main barriers for them, which in this case, time was the biggest one. Environment setup, unwelcoming community. Like there are some people who had a really bad experience in the survey that they talked about, and there are some that even helpfully recommended some projects not to go anywhere near because of the people that are on those projects. And the other thing was like lack of skill or not confident enough that they could even contribute. These are some other little kind of things that came out. So 7 people got started thanks to Google Summer of Code or other women in open source projects. 5 people got into it thanks to Linux CDs found in like cereal boxes, randomly enough. GitHub was mentioned 15 times. Only 3 people said that they were primarily drawn to open source because of like freedom and I guess ethical values. 6 people said starting was easy and not hard, but 21 people gave barriers to getting started. So for some people, it definitely seems to be a lot easier than it is for others, which I guess, would be kind of expected. There was also this. So as a UX designer, it's not clear how we can contribute or if our contribution is even welcome. So things like this are quite interesting as well, because I think that open source communities would really benefit from having people that aren't just developers and things. And I feel like, having UX designers or people from outside of that community would add a huge amount of value to those projects and probably improve like the uptake of people who are casually using open source software as opposed to proprietary software. So yeah, I thought this was quite telling. I also had a look at other studies who did actual research on this stuff. This was one of the diagrams that they showed, so I'm not going to go into all of these. The red ones are social aspects, but I think in total there's like 35 responses here or something like that, or possible reasons for why people have a bad time contributing. So these are the barriers for newcomers to open source software. One of the biggest themes was that flame wars are bad, said a lot of people, which kind of makes you go like, why is it so bad? And there seems to be this thing where if you're writing code, you have to justify it, and there's a strong social aspect, which means that you get into these discussions on the internet, and some people are effectively anonymous, or just because you're not talking face to face, people are more likely to say like rude or offensive things. But there was some interesting things like, for example, for women, if they're witnessing an argument, then they're more likely to be affected, so get physical responses of anxiety. Whereas for men watching an argument happen, they think it's kind of funny. They just kind of like laugh at it, unless it's directed at them, in which case they get very upset. Also, for a woman, and some people of different cultures don't like bargaining. So some people would rather than bargain the price down of a car, they would rather just spend the extra $1,000. And there was a study that showed that. So yeah, it can be really tough. This one here is a particularly annoying problem. So I'm sure you're all familiar with this, which is, read the fucking manual. So this is like just a really not great way to onboard people or make people feel welcome in projects. There's also a lot of discussions around when people get into the topic of gender in these communities. Often they're just like, but it's just a social construct, and gender doesn't exist here, which is absolutely not true. So yeah, that can also be quite a problem where people kind of form into these arguments. Like I think even recently there was a tweet from the founder of Docker saying, what if we had like a totally anonymous version of GitHub, which is really not a great idea. Because they can for one thing, it's like not really going to be anonymous, like that would just be too difficult to do. But the idea behind it is that if you have just code, then nothing else matters, and therefore diversity is not a thing. But you're still going to have a problem where people who are non-English speakers who are struggling to communicate and contribute, there's going to be biases against that, and code doesn't speak for itself. This is like another popular belief. It turns out that people, like I said before, you have to justify your code, and essentially what seems to happen is the more loudly that you justify it, then the more likely it's going to be accepted that your code is better, which is not really great. There's also this kind of conflicting idea, which is some people say good code works, bad code doesn't. But then you might also have beautiful experimental code, which is pretty unlikely to work, but it could be seen as like pure genius. So all of these kind of conflicts are settled by flame wars, essentially. And it's really not good. It's not good for people to have this happen. This is an example of some community guidelines that I've seen, which I really like, which is kind of outlining what you want to focus on. So focusing on experiences and practice seems to be a lot better than interest and identity, because as soon as people get really tied to things as part of their identity, it becomes like personal attacks and stuff like that, which is really not great, and can kind of, it breeds contempt culture as well. And I'm not sure if you're familiar with the term contempt culture, but there's this really amazing blog post written by Oren out there that's very good. I absolutely recommend reading it, because it talks a lot about that whole like, but PHP really sucks. People who program in PHP are just the worst. They're such bozos, or whatever, like stuff like this that just doesn't help anyone. And it's kind of treated like a way of, currency, in a sense of like, I've got to show that I know a lot, so I'm going to push down everything else, and just perpetuates, like, again, like more shitty stereotypes. All right, moving on. Where will the newbies come from? So youth coming through digital technologies is taught. So for example, people who are learning computer science in schools, they'll probably get more students who are exposed to it coming through. There may be senior people who struggle to find work. This seems to be something that's becoming a little bit more common, where people are doing career shifts. However, there is the problem of ageism. So this seems to be more applied to people from like open source communities, where they can kind of hide their identity a little bit better. People who are going through a career change, and people from countries who may or may not be going through some serious stuff right now. So for example, some people are showing like some forms of like resilience, or being able to do some kind of work in countries that are conflicted by war and stuff like that. So that's quite an interesting, I guess, side effect of that. So here are the key takeaways. Here are the real takeaways. The point is that you exist in a social context, and tech is not a meritocracy. Flame wars absolutely need to be reduced. There are some ways of there are some concrete ways in which you can try and reduce those. There was I saw a really good talk at Linux conference this year that was about that, and there's definitely some really good resources online on some strategies on how to reduce those. Have useful documentation and guides for beginners, like having a good starting point, or somebody that you can talk to, or people who are generally friendly, that don't make assumptions, is really important. And also remember to welcome non-coders, or even to talk to non-coders about what you do, and explain it in a way that they can understand without using lots of jargon, because they could actually be really interested. They just might be a little bit intimidated. Anyway, thank you very much. Sorry that I went like a tiny bit over time, but I hope you enjoyed it. I'm going to stop sharing my screen now. Let's go stop sharing. All right. Yay, thank you. Let me just check my inbox, because I think there's an answer. You can send me questions. Okay, no questions. Did anyone have questions there that you wanted to ask me or anything? No, maybe.
Thank you. I prompted everyone if they have questions. All right, here we go.
Oh, can you hear me, Grace?
Yes, I can.
I kind of. You said that when you're doing your gender parity research, you faced some opposition. What kind of opposition did you face for the research you're interested in?
So one of the things that happened was early on, I kind of proposed the idea of doing this. I proposed the idea of doing this project to a bunch of different people, including the head of department at my university, and the head of department was like, "Oh yeah, but maybe we should have somebody who is from like sociology, or somebody who's like better at it." And also my grades were like all over the place, and this lecturer knew that, and so they're like, "Oh, maybe you want somebody who's like more reliable." Is kind of like what he said in not so many words. So it was kind of, I guess, made fairly clear. Like at first, this kind of seems like a little bit of like a knockback of like, oh, okay, head of department is like, oh, don't want to do this. Or, some people will just kind of say some things really that wasn't so good. But it was lucky that the registrar of the faculty who went and like organized this essentially, that she kind of took care of that and kind of did it along the side, if that makes sense. So like she managed to find funding in a slightly more indirect route, which enabled me to do this project. But yeah, it kind of sucks when the head of department's like, nope, we're not interested in this. Are there any more questions? Oh, there's one at the front.
Hi, Grace. That was super interesting. Thank you.
Thanks.
I'm really interested in what you're doing now as well. I mean, you graduated recently, and you did all this research in gender disparities and situations like that in New Zealand. But what are you doing now? Are you still kind of furthering any of this, or in your job at the moment? Do you do anything in your company or whatever you're doing?
Yeah, good question. The answer is kind of not really. Like I mean, all of this is kind of on the side. Most of like the research that I've done, so it kind of depends on what kind of opportunities come up. Like I've definitely found that submitting a talk and then having to promise to deliver something really helps kind of push my research along. But I guess I'm kind of like, I've got a few side projects on the side, but I'm kind of mostly focusing on my own like technical development and trying to improve in that way. I did recently write a blog post about command line tools for beginners, which if you're interested, I can send to you. I made it really funny and like tried to make it really welcoming. So I kind of do stuff like that on the side every now and then. But yeah, I've just kind of been taking a little bit of a break from gender research in particular, because it's quite, like, I guess it's quite hard work, especially when there's people who are not necessarily like interested. But my organization is a little bit different in the sense that they they only have like a really small development team, so it comes with like a whole different set of challenges, and I'm a little bit more disconnected in a way from some of the other difficulties in tech, where like, for example, at university, the problems were like right there in my face, being like everyone was miserable and I was faced with that like every day, which really kind of like gave me the impetus to like research more, if that kind of makes sense. I don't know if that answers your question, but
Yeah, it does. Thank you very much.
Hi there. Thank you for taking the time for speaking about all this. We were wondering what was the name of your book?
Oh, so the research project that I did, I think it was, let me just find, it was like gender parity in computer science at University of Waikato, I think. So yeah, recommendations for reaching gender parity at University of Waikato. And it's about, I think like 30 pages long or something. So it's quite short. It's just like quite a small, I guess, relatively small research project. Yeah. But yeah, if you email me, I'll send it to you as well if you're interested in reading more and checking out like the references and stuff, because there is heaps of information that I couldn't include in this talk. Anything else?
Great. Thank you so much, Grace. Really appreciated that talk. Super interesting. We're going to go ahead and move on to Chelsea's talk on data science in discovery.
All right, awesome. Thank you for having me.
Of course. Thank you, Grace.
Bye.
Bye.
Hi, girls. My name is Chelsea. I'm the data analyst at Discovery Department in the Wikimedia Foundation. Today, I'm going to talk about our data science workflow at the Discovery. So, before I start to talk about my job, let me give you a brief introduction about what Discovery Department do and what does data analysts do in Discovery. So, the mission of Discovery Department is to make the wealth of knowledge and content in the Wikimedia project easily discoverable. And we are responsible for the following project. We are responsible for maintaining and enhancing the search features and APIs on for MediaWiki. And second, since many people discover Wikipedia through wikipedia.org, we are also responsible for improving the user experience for those visitors. And then we are also trying to include OpenStreetMap tiles in all the Wikimedia project. And lastly, we are building a Wikidata query service to help users to search structured data on Wikidata. And as data analysts at Discovery, we are responsible for providing ad hoc analysis and reports as needed. We do analysis from exploratory data analysis to model building to solve some complicated problems. And we are also building and maintaining dashboards for checking key performance indicators and other metrics. We also consult with teams in design of A/B tests and then analyze and report the result. And lastly, we work with engineers to design and implement event logging schemas. And we use R for almost all of this project. Next, I wanted to focus on two main part of our job to show you how we use R in our day-to-day work. So the first thing I want to talk about is our dashboard. We build all our dashboard using our Shiny package. And our dashboard contains everything from API usage to direct user interactions and provide data for internal and external use to see how well we are doing. And this graph shows how we create our dashboard from the raw data. So we have two main data sources. One is the web requests. So web requests are the logs of every HTTP and HTTPS request made to all the Wikimedia sites. And we store them in a Hadoop cluster. And the event loggings are checks the user side's event, and we use it for things like how often do users click through to our search results, and we store them in a MySQL database. So, and then we use a SQL or Hive query to pull the data from our database and then do some aggregation and remove the personal information in the data. And sometimes we'll use R to do some further process. And these scripts are scheduled to execute it on a daily basis and then we publish the aggregated data to datasets.wikimedia.org. And then finally, on the dashboard side, we pull the data over HTTP from dataset.wikimedia.org and then use Shiny to build our dashboard. So Shiny package itself already provide a lot of widgets and basic graphs for the interactive visualizations. But there's a lot of other packages out there that can let you create very beautiful interactive graphs. So, oops. So let me show you with some example on our dashboard. Okay. So this dashboard shows the traffic from shows the traffic to the wikipedia.org, and we are breaking down the traffic by countries. So you can see here on the first row, we put a widget to let users select the data range, and you can also select the metrics you want to show. And then You can select the group of countries you want to show. You can even customize it by typing into the box here. And you can also select the smoothing method here. And then the first graphs here is a pie chart we created by a package called High Charter. And so on the outer ring are the all the countries that we have traffics coming from. And here on the tooltips, you can see the name of the country and the number of visits from that country and the proportion. And I want to mention that the number is not the exact number that visit wikimedia.org, since when user navigate to wikimedia.org, we randomly select the sessions to be checked by our event logging schema. So these are just the number of sessions that's been checked. And in the inner circle, we group the countries by the continent. And you can also click on the continent, and then it shows the pie charts for the countries within that continent with their proportion and number of visits. And since many of our traffic come from United States, we also break down our traffic from United States by the region. And the next thing, so this line graph shows the time series for the number of visits. So we create this graph by a package called digraphs, and there's a lot of things you can play around with too. So you can select the date range you want to show, or select a session on the line to enlarge it. And we also put a data table here. So this is created by the DT package. Um, you can sort the table by whatever metrics you want. And you can even filter the table by typing in the search box here. And we also put a button down here to let you download the CSV file for this data table. And lastly, we use a markdown file to document the things we do on this page, like what this metrics means and how we compute them, and if there's any issues with the data. Yeah, so beside the examples I just showed, so there's a lot of other package there as well. For example, like these more sparklights here are created by a package called Sparklight. And you can even embed this Sparklight in a data table, the DT data table. Yeah, so Shiny is very powerful. It allows data analysts to create a very fully functional dashboard without knowing any JavaScript. And there's a lot of great documentation for Shiny there. So you can check out their tutorials, articles, and galleries. And also Shiny is very customizable with a little bit JavaScript code and CSS code. You can make it to whatever style you like. Um, yeah. So the next thing I want to talk about is our research and testing. Um, although every project is very different, but in a typical data science project, there are some common steps, and there are some packages that you use for almost every project. So we normally start with retrieving data, and we use reader package and WMF package to accomplish this task. So WMF package is our open source package for querying Hive and MySQL database internally. And then we use dplyr and tidyr data table and many other package to refine our data. And then after that, we use ggplot to do exploratory data analysis. And I want to mention that the most package in the first 3 steps are now in a collection called tidyverse. So now you can just load tidyverse without loading this package individually. And then when we come to the model and analysis steps, it really varies the package use is really depends on what the problem is. We'll use binom, BCDA, random forest to solve different problems. For example, when we do analysis for A/B testing, we always use binom package to compute the Bayesian credible interval to see if a matrix is significantly different between our test group and control group. And then finally, we will use Markdown and Meetup package to create a reproducible report. Next, let's see some example for from our job. The first example is the exploratory data analysis. So it's about how long do users stay on wikipedia.org. So like I mentioned before, when our user navigate to wikipedia.org, they are randomly selected at a 1 in 200 rate to be checked by our event logging schema. And if a user is selected, we'll set a 15-minute timer, and if the user come back before before the session expiration, we will renew the timer for another 15 minutes. But if they come back after 15 minutes, we will stop checking them and then clear the local storage. So the 15 minutes is just an initial guess when we put the schema together. So the purpose of this project is to provide a reference point if we wanted to adjust the 15 minutes. So you can see here, this is a density plot of our session length. We can see that the most common session length is about 10 seconds. And the majority of sessions are shorter than 1 minute. And here on the link, this is the link to the full PDF report. So we put a lot of detail about how we process the data here and a lot of the exploratory data analysis results. We also break down the session length by click-through, by the number of visits. And here we put the survival curve by the top 30 languages. So each gray curve stands for the survival curve of one language, and the black curve is the smooth medium. We also highlighted the English using session and Russian sessions by blue and red. So here, this point shows that 48% of the English using sessions lasted longer than 10 seconds. And however, 66% of Russian using sessions lasted longer than 10 seconds. So we can see clearly that the blue line is under the black line, which means that our English sessions is shorter than average, while the Russian using sessions are longer than the average. And there's a lot of other results down there, so feel free to check out this report. And we also put all our analysis code base on GitHub. You can see we organize all our code by the steps in our workflow. So this is the script to retrieve data. This is for exploratory data analysis and refine the data. And we also include a header.txt file in our Markdown report to select the font and the color we want to use in the PDF report. So, okay. So that's the first example. The next one is an analysis for an A/B testing. So our discovery search team is trying to improve the relevancy of our search results, and we want to try a new search ranking function. We did a first A/B test on English Wikipedia, and it turns out the search ranking function works very well. We are showing our users more results, and our users engage with the results more. But then our engineers realized that this ranking function might not work very well for languages that don't use space to separate the word, like Chinese, Japanese, and Thai. So we decided to do a second round of the A/B test. And we are interested in comparing the following metrics between our control group and test group. The first thing is the zero result rate, which is the percentage of searches without any results. And we are also comparing pause score, which is a measurement of relevancy based on the click. And of course, we are interested in the user engagement. So we are comparing click-through rate, position of first click result. And then we also want to know after the user click to the search result, how much do they like the result? So we also look into the time they spend on the visited page and how often do they scroll on the visited page. And finally, we wanted to see how often do users reformulate their query, because we are assuming that if our users satisfied with the search result, they will less likely to reformulate their query. And so you can open, so we put a full report for this analysis on GitHub pages. You can open this link. So this is the HTML report we create. Also, we put background, how we process the data here, the aggregation table, and of course the results. Here we can see in the test group, the zero result rate for the test group is lower, which means that we are showing our users more results. But however, when we come to the pause score, the test group's pause score is getting worse. And the click-through rate for the test group is getting much worse, which means that we are showing our user more result, but they might not be very relevant. And we should not implement this search ranking function for those languages. And of course, here on the top of the page, we put a link to our Markdown report and the analysis code base. And comparing to the PDF report I just shown before, our Markdown allows you to add more features with the HTML report here. So for example, we add a little bit, here you can let the users show or hide the code. And we add a little bit JavaScript code here to let user click on the image so that they can see the full resolution of the image. And we also use a package called Captioner. The package allows us to have a finer control over the caption. And then also, you can add with that package. You can add captions for not just the figure, but also tables, the code snippets, and you can even referencing a figure within the title of the figure, combining with ggplot2. Yeah. So that's it. And yeah, so I think in every data science project, there's a roughly 80-20 rule. Like about 80% of every project can be solved by the same tools or the same packages. And so if you have a solid foundation of in those tools, that your work efficiency will be improved largely. And I also wanted to recommend a book by Hallie Wickin, The Art for Data Science. I think this book covers many packages that we use for the 80% of the job, and it has a lot of great details and examples. And that's all of it. Any question? Thank you. We are the goal of our group is to make anything make this Wikimedia and the articles on Wikipedia more easily discoverable. for example, like I talked about, the main job of our group is like improving our search engine. So we are trying to make our users find the information they want more easily. And also like the other projects to like the project related to wikipedia.org, we are trying to uh, ha- let users have a better user experience on wikipedia.org, so they will be more likely to click through and read article on Wikipedia. Yes. Yes. Yes, yes, actually, most of our traffic come from Google. Yeah. Yeah.
Hi, Chelsea. Thank you for the presentation.
Thank you.
I have a couple of questions, if that's okay. One more or less relates to her question. I was wondering if you could elaborate a little bit about how the analytics group is organized within Wikipedia. What's the composition of the group? Is it centralized? Is it decentralized? Or how it works? That's my first question.
Um, Currently, I think we only have 4 people whose title is data analyst, and we have 2 data analysts in discovery department, one in editing department, and one in the reading department. So we are kind of like decentralized, and but we talk to each other all the time, of course. Um, but I don't know, like we are also thinking about like maybe things can be changed, and we may be uh, become a centralized data science team in the future, but I don't know yet.
And my second question is more technical, is more like a curiosity. You mentioned that you guys have been using OpenStreetMap tiles.
Mhm.
Could you elaborate a little bit more on that?
Um, and actually, I'm not very familiar with that project. I'm not the because we have another data analyst. I'm not the main person who support that project. But if you're interested, I think you can check out our website. There's more detail there. So there's a page for discovery department. So here you can see what the maps team's doing, and I think they have some demo of their work there as well.
Hi, Chelsea. That's a very interesting talk. I got a lot
you.
from it, so thank you very much. And I just have a quick question. So I'm very interested in the usage time where you guys tune when you check user are still idle or active on the web page. So for that project, is that public in GitHub and like available for public consumption, or that's just more for you guys
Yes,
share internally?
it's public. You can check out all of our code in our R Markdown file.
And that's like from the Wikimedia page?
Yes, it's um if you're interested, I can share the slides. I'll put a link of the slides on the Meetup page, and here on the slides there's a link to that report. So feel free to check it out.
Thank you very much.
Hi.
Hi.
Thank you. I really like the talk.
Thank you.
I'm working through reading R for Data Science now, and I was wondering if you had any recommendations from your personal experience of building up experience and kind of getting to the point that you're at now, and if you have any kind of open data sets that you recommend working with, or any of the expertise that you talked about with the 4 different packages, just any suggestions you have in gaining momentum. It's kind of an open question, but maybe how you started, or just some projects to get started with.
Project to get started with. I think, well, because my background is statistics, and I've been training to use R when I was in school. So I kind of learned R from school, but so I might not be very able to give a lot of advice on like self-studying thing, but I think you can try something like, have you heard of Kaggle?
Yeah.
Yeah, I think there's a lot of open data set on Kaggle, and there's some competitions there. And I think there's a lot of people writing tutorials on how they solve a problem. And I think as a starting point, you can just read the tutorial that those people write about, and just following read their code and trying to replicate their analysis. And I think it's a good way to learn at the start.
Okay. Are there any people that you follow right now, or like kind of people whose work that you?
Right now, not really. I kind of like learn in my job. Yeah.
Okay. Thank you.
Oh, I was just curious, what you do in your department to like review code, like for each other, or like I guess how do you check for the quality of your programming?
Yeah. So there are two data analysts in my department. So me and the other person, and we always review each other's code and review each other's report. So is that what you want to know?
Yeah, yeah. I was just,
Okay. Yeah. Yeah. I think that's very important because we always make stupid mistake, and it's always good to let the others to check your work. Hi.
Oh, hi. Thank you so much for the talk.
Thank you.
I have a question, which is that those shiny dashboard that you're showing earlier,
Mhm.
are those open to public?
Yes.
Okay, cool.
Yeah. Yeah. I also put the link to all our dashboard here. Yeah. We have 5 dashboard in total. Hi.
Cool. So I have a related question. So usually when you make shiny dashboards, you kind of have to run them in R, and you
Mhm.
have to like have an R process running underneath. Like it doesn't just export as an HTML.
Mhm.
So how, I don't know if this was something that you did or someone else who knows more about web stuff, like, but like how do you put your shiny dashboard like on a web page?
So right now we are running our Shiny dashboard. Run a Shiny server in a Vagrant virtual machine on one of our server, and so it's been so the setup of this whole thing has been held by other colleagues in the Wikimedia Foundation, but me and the other data analysts are also learning to try to like when there's a bug, we are trying to solve it by ourselves, and so we are learning a lot about like how to maintaining it also. Yeah. Hi.
So it's just a. So how do you define a session? Because you're measuring the amount of time, per session. How do you define a session? If it's just I open the web page, it's just the amount of time it stays on that page, or if you switch to another page. Well, let's say if I go, if I'm browsing Wikipedia and then I go to bed, and next morning it's still there. Do you consider that entire session one session?
Sorry, can you say one more time?
Sorry. Session, because you had a plot of the amount of time spent per session, right? You're saying 10 seconds maximum, not maximum, a lot of people mostly 10 seconds per session.
Yeah.
My question is really, what is a session? How do you define a session?
So when a user, you can roughly take a session as a user. So when a user navigate to wikipedia.org, then it starts a session?
Yes. But my question is like, if I leave the, as I said, I'm just like browsing Wikipedia. So I open and go to wikipedia.org, whatever page, and then I go to bed, and then next morning shoot there. How do you account for that? That's my question.
So that's so if you leave before the 15 minutes and we stop checking you, and when you come back the next day, if you are selected again, then we'll start a new session.
I see. I start a new session next day. Okay. I see. Thank you.
Yeah. No, if you come back before 15 minutes, we will renew the timer, and so will set so it can be longer than 15 minutes. Yeah, one session. Yeah, if you leave, if you stop browsing the page, then after 15 minutes we won't check you anymore. Yeah, so and you're just staying there, so we'll stop keep checking you. So if you're browsing there, you have some action, like if you scroll, we can check the scroll action there. Yeah. Yeah. Uh, yes, this dataset.wikipedia.org. Yeah. 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 Yeah, there's actually many other data set which is public. So except so there's a lot of so this data set are public. So if you are interested in, you can do any research you want using this data set. And I think the foundation also publish many other aggregated data set somewhere else. I can't remember off the top of my head right now, but there's many other websites there that publish our data set, and feel free to use them, do whatever research you find it interesting. Yeah. What do you mean by content? Um, I don't know, because but I think you can. I don't remember anyone have do such aggregation, but I think it's a very interesting topic, and I think someone is doing some research about it, and I can't remember neither, but I think with the public data you will be able to do that. But of course the category of the Wikipedia page is a mess. It's a mess. So we are actually working on it and trying to make it more structural. Yeah. 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 Yeah, because many of the category, it's created by human, and they are not very structured. Yeah. Any other question?
Any other questions for Chelsea? No. Thank you so much, Chelsea. That was great. Thank you.
Thank you.
So now we'll open it up to networking. Our director of recruiting, Amy Elder, is sitting right here in the back. So if anyone wants to swing by and say hi and maybe ask any questions, and then our senior technical recruiters here as well. So feel free to swing by and say hi. And thank you so much for all coming on a Tuesday night. We really appreciate it, and we hope you enjoyed the talk.